Hi everybody, welcome back. We are now on 9-1 linear inequalities of two variables. We're going to look at some of the inequality signs just to re-familiarize ourselves with these symbols. So it just says the speed of a limit on the highway is 100 kilometers per hour. A car is breaking the speed limit, so this means that the speed s at which the car is traveling is given by the inequality s is greater than 100. So an inequality sign must contain one of the following symbols, so inequality signs. So the first one there is less than or equal to. The second one you see on your page here is greater than or equal to. The third here is less than, and the final one here we have is greater than. No order, of course. So here are some examples of linear inequalities in two variables. So y is less than or equal to negative 15x minus 10. 3x plus 2y is greater than 5. 4p minus 2q is less than 8. The solution region to a linear inequality in two variables can be represented on the coordinate plane using a boundary line. So just like we did in Math 11 with the linears, it's very similar, so you guys may recall some of this. Just we're going to bring in basically quadratics as well, and two variables and one variable. So we're going to talk a little bit different. So it's not completely new to you. So as you guys do recall, the solid line, when you are graphing an inequality, has the equal sign included, so less than or equal to or greater than or equal to, and the broken line, or sometimes we'll hear it as a dashed line, that is less than or equal to. How to graph a linear inequality in two variables. Here's an example. It says, graph the following linear inequalities in two variables. Y is greater than 3/4 x plus 3. So you'll probably look at that and say, yeah, okay, that is a linear inequality. It looks very similar to y equals mx plus b, and you'd be correct. So remember, we're going to use the dashed line on our graph here due to the fact that it doesn't have an equal sign. So we call it a broken or a dashed line. It's already in form y equals mx plus b, so for this particular graph, we could start at 0 and 3 because we know the y-intercept is the b value, the plus 3 here. And then I just used the slope of rise over run, so up 3, right 4 is the 3/4, and that's your m value, right, your slope. And then we use a test point. You guys may recall the test point to shade which side you're going to shade on, right, the left or the right. This allows you to determine where you're going to shade. So I use the 0, 0. You can clearly see here that it's not here, right? I guess I can go back and show you how to graph the linear line. I don't think that should be an issue here, but you'll see the point here at 0 and 3, and then we go up 3 over, so up 3, right 4, up 3, right 4. Again, you only need two coordinates to graph a linear inequality. So I put the test point in. 0 is greater than 3/4, 0 plus 3, 0 is greater than 0 plus 3, 0 is greater than 3. And we know this is not true, so since this is false, we shade the region that does not include the test point 0, 0. And there's your graph there. Remember to include, my Desmouse doesn't show, remember to include arrows at the end of each line, and that way you can ensure that you're showing that the graph doesn't continue on forever down and to the left and up and to the right. Okay? Let's look at a second example. Second example says 2x minus 3y is greater than or equal to 12. You may recall when we graph these linear inequalities, or graph the linear equation, when you have a graph in this form, the easiest thing to do, you could rearrange the formula for y equals, or you could just let y equals 0, find the x-intercept, do the same, let x equal to 0, find the y-intercept, plot the 2 points, and connect them with a linear line. And again, since this here graph has greater than or equal to 12, then we know that it's going to be a solid line. So that's why you don't see anything broken in your graph here. Okay? So I just graph 6 and 0, which is right here. And I graph 0 and -4, which is right here. And like I said, since it's greater than or equal to, we use a solid line. Pick a test point 0, 0 again. So 2 times 0 minus 3 times 0 is greater than or equal to 12. 0 is greater than or equal to 12, which we know is false. So therefore, you don't shade the region with the 0, 0. You shade the opposite side, right? And then this third example, very similar to what we did in the last one. This time, we can't use the test point 1 and 0 and 0 due to the fact that our graph runs right through with the origin 0 and 0. So yeah, just remember 0, 0 is not always going to work. It'll always depend on your graph. Of course, this one here went through the origin, so we couldn't use test point 0, 0, so I just used 1 and 1, which is right here. Clearly not going through here. Again, I did this one. It was set up for x and y intercepts, but I decided to show you how to do solving, right? Rearranging the formula for y equals mx plus b. Notice that the sign changed. It was less than or equal to, and now it's greater than or equal to, and that's due to the fact that we divided by negative 20. As you hopefully recall, when you are working with inequalities and you divide by a negative value, that will cause the inequality to change the ways, right? So if it's less than or equal to, it'll become greater than or equal. The symbol will change signs, right? Again, and remember, this is a dashed or broken line, so therefore it's dash. We don't close it. The test point is 1 and 1 because 0 and 0 is one of our coordinates on our linear line. I tried 1, 1, so it's negative 15 is less than 0, which we know in fact is true. I always put it back in the original. You can put it back in here. It wouldn't matter. And since it's true, we shade the region with 1 and 1. Again, these can all be done on the Desmos program as well at home, and you can work through these on the graphic technology, which I know you don't have at home. But when you're working with these, I'll bring in the Desmos program for you. Remember, we use Desmos here, start graphing, and you can literally put these in as you see them. So we'll flick back to our graph. We have 5x minus 20y is less than 0. Minus 20y is less than 0. And you see that graph there. It shades it for you. This is a great check for when you're doing these by hand, and you can just take a look to see if your graph looks similar to the ones that we've done there. So it's a great resource for when you're working with those for sure. All right, let's look at the example of when we need to find the equation. So now we're given the graph, and we're going to actually come up with the equation. So it says the diagram shows the solution region for an inequality. Determine the equation of the boundary line and hence determine the inequality. So it's linear, so I use y equals mx plus b. It clearly goes through at the point 0, negative 3, so there's your b value. You could pick another point to define the slope, so I got the negative 3. You could clearly see that it was going through at an x-intercept of negative 1, so that means I went down 3, right 1. So it's down negative 3, and then it's over 1. We don't need to show that. So it's negative 3. And then to make the inequality true, you can do the test point if you wish. It's up to yourself. And that's all I did. I picked 0 and 0. I plugged it in. 0 is something to negative 3, because if we put 0 in here and 0 in here, we'd get 0 subtract 3. Right, so we'd have 0 on the left-hand side of the inequality. We'd have negative 3 on the right-hand side. So 0 is not less than 3, right? So that 0, 0 is not true. It's false. So then that's part of the shaded. So that's where the inequality comes from. Again, you can throw that in the Desmos just to check it out for you as a quick tool to take a look. But it's basically working backwards. Here's another one. Goes through at 4, so there's 4. Your slope is going to be slope of 3. Remember, we got to go through it exactly at a point, right? So if you look here, there's a point here at negative 1 and 1, and a point at 0 and 4, so it's up 3, right 1, so that's where the 3 comes from. and we use 0, 0 as a test point. 0 is less than or equal to 4, which we know is true, so we want that to be true, so that's why we keep the sign. It includes. This one was the opposite, because we had 0 in here, -3, and to make that true we had to put in our, the opposite sign, right? Because 0, 0 wasn't tested, right? So you could pick a point that is shaded region and want to go opposite. It's completely up to yourself how you want to figure that out. And the last question here on section 9-1, it's a little word problem. It says you would like to make a mosaic using tile and stone, so that's just like a pattern. The tile costs $2.50 a square foot, and the stone costs $7.50 per kilogram. Your budget for the mosaic tile is $60, but you want to have a mixture of both. So it's just write an inequality to represent the two. So I let x equal the area of the tile, I let y equal the mass of the stone, and then I set up the inequality using our price point. So it's $2.50 multiplied by the tile, x, $7.50 multiplied by y is less than or equal to 60. I solved it using, again, you could use x and y intercepts here, or you could switch it into y equals mx plus b. It's completely up to yourself. And there's the line that would be for your linear inequality. You'll notice I didn't use anything for quadrant 2, quadrant 3, or quadrant 4 because you're not going to have a negative area, you're not going to have a negative mass. So everything quadrant 1, as you guys remember from class, we do a lot, when we do a lot of these word problems, that we only include quadrant 1 where everything's positive. And it says pick any two coordinates that would satisfy this inequality. So I picked 2 and 7, which was right here, slightly under, and I picked 18 and 1.5, which is right here. So you can have different combinations of both to satisfy that region, right? Okay. And again, if you want to make sure both the 0 and -24 and 0 wouldn't do that, because then you wouldn't have a little bit of either, right? This here, 24 and 0, means you're going with all tile. This 0 and 8 means you're going with all stone. Okay. There's some homework questions, just some recommended questions to work through. Page 472 of your textbooks, numbers 1 to 4, 9, and 11. So that's it for 9.1. If you have any questions, please let me know. And we'll see you again soon in 9.2.